Hello students, welcome back. So in this session we are going to discuss the trigonometric functions, different functions, how to know the formula. So here we don't have to derive it, but these are the list of formulas of differentiation which you have to remember in physics, because mostly they will be used directly. You have to just use these formulas. So let's see first the trigonometric functions. What are the formulas? So differentiation of sin x is cos x is minus sin x, tan x is secant square x, cot x is minus cosecant square x, secant x is secant x tan x, cosecant x is minus cosecant x cot x. Okay, this you have to remember. Now, uh, you need to remember some modifications that can happen. Like, for example, suppose it is differentiation of, let us say, sine ax plus b. In general, I am giving this angle is sine ax plus b. Okay, differentiation of sine is with respect. So here directly you remember sine differentiation will be cos. Okay, ax plus b, and then the coefficient of x, which is a, will come out. This is what you have to remember here. Okay, the coefficient will come out, coefficient of x. How it is coming? It is coming by chain rule. So similarly, if it is cos ax plus b, formula will be minus, right? For example, suppose it is differentiation of cos of ax plus b. A and b can be any constant. Okay, now this differentiation will become minus a, you have to write because that's the coefficient, and minus sign you have to write sign of whatever it is. Okay, so minus sine ax plus b, and the coefficient is getting multiplied. Okay, this you have to note. Same way you can do. So this for linear kind of a function. Linear function means you can see here it is like ax plus b. It's a linear function of x. When the angles are in linear function of x, then we can do like this. But if it is a non-linear, then you have to further apply chain rule. Then you can do that. Okay. So this is one type of formulas which you have to remember. Then next, polynomial functions. Polynomial functions you will see in most of the kinematics. Okay, so here this formula, this one you have to remember, is the most important formula. Differentiation of x power n with respect to x is n into x power n minus 1. Okay. Other things, constant differentiation 0, dx by x is 1. Differentiation of 1 by x is also going to come. It will come particularly in electrostatics chapter. Okay, 1 by x differentiation is minus 1 by x square. And differentiation of root of x is 1 by 2 root x. This formula also you remember. Although this formula can be derived from this third formula itself, but still you can remember this because it will be directly, you don't have to confuse and calculate again and again. So better if you remember third, 4 and 5 also you remember. Okay, here also if there are like similar chain rule you can apply. For example, differentiation x, for example, take it is general ax plus b power n. So when you are going to do differentiation of this, so you will write n into x. Here instead of x, this whole term is there, right? So ax plus b power n minus 1 you will write, and again the coefficient of x, which is a, should be multiplied outside. Okay, you have to multiply the outside like this you have to do. Okay, because it is chain rule. Chain rule you have to apply and do. If it's a non-linear, then again chain rule you have to do that. Okay, so this type of equations, formulas you have to use. Next, exponential functions. Here a per power x differentiation you have to remember a per power x ln a. In this, if you substitute a equal to e, if you substitute you will get equation number 2, right? Because ln e is equal to 1. What is ln? Ln means ln a means it is log base e of a. E is irrational number, you know that. 2.718, like that. It's a rational number. Okay, then x to the power x is this, x to the power x 1 plus ln x. These are again coming by chain rule. Similarly, here if there is modification in this, for example, differentiation of, let's say, with respect to x, you have some other thing. For example, let's say a per power 2x plus 3, like that it is. Okay, so here you can apply the same rule, a per power 2x plus 3 with respect to 2x plus 3, right, and differentiation to x plus 3 with respect to x. So chain rule can be used to modify a lot of formulas. So a per power this with respect to this is a per power this into ln of a, that will remain, and here this factor 2 will come out, right? So like this you have to do all the calculations that will be done. Okay, like that you remember. Then logarithmic functions, here two formulas are only important. Log a x, differentiation with x, is 1 by x ln a, 1 by ln a. Okay, so ln a is, remember, it is in the denominator here. Okay, and ln x differentiation with x is 1 by x. Here also modification can happen. For example, they give differentiation of ln ax plus b, right, with respect to x. So this will become 1 by ax plus b, right, and again you have to multiply the coefficient of x, right, a you have to multiply. So like this, all these are based on chain rule modification, you can do that. Okay, then inverse trigonometric functions. Inverse trigonometric functions you won't see much application, but still I have given here the list, you can just refer to. Sometimes they will be used in integration mostly. So in, because integration will be opposite of differentiation, so there we can use. Okay, but still you remember is sine inverse x, okay, with respect to x is 1 by root under 1 minus x square, like that. Cos inverse x with respect to x is minus, there is extra minus term coming here. Okay, minus 1. Same with tan inverse x is 1 by 1 plus x square. Okay, cot inverse x is minus 1 by, second inverse x is 1 by mod of x, this is mod of x here. Okay, root under 1 x square minus 1, cosecant square x, there is a minus 1 mod of x, root under x square minus. So this formulas you can remember, but here you won't use this one, it won't much be coming in the calculations. Okay, hyperbolic functions also not going to come, but still I am giving what is hyperbolic function mass, you will be seeing about this, right? Sin hx, cos hx, will not go more detail about this. So this differentiation is same like like trigonometric functions, right? Okay, then these are the formulas. Then similarly inverse hyperbolic function, this also you are not going to use much, but in integration it may come. So here all these list of formulas I am giving. Okay, so these are the things for this. Then we will be seeing the integration. Okay, next. Thank you.